All right, so for today we have, this is chapter 6.1, and we're going to try and find without a calculator. Okay, without a calculator, we're going to find this stuff. So, like I said, I'm going to show you guys a really easy way of doing it, and then we're going to go back and do a little bit of a harder way. But it works out. Anyway, so I'm going to first focus on this right here. I always have to start from the inside. Okay, always start with the inside. So from the inside, they gave me tangent, and we know tangent is what? Y over x, right? Or sine over cosine, right? So my y value here is 3, right? My x value is 2, and what am I missing? I'm missing the r. So the r value is missing. So I'm going to use Pythagorean theorem to find my r. So I should have 2 squared plus 3 squared equals my r squared. So 4 plus 9 is 13. So r is equal to the square root of 13. This one cannot be plus or minus because it cannot be a minus. R is always my radius, and that's always going to be a positive number. So therefore, this has to be a positive 13. Now, given this information right here from the inside, what am I asking for out here?
Sine.
The sine of this. So the sine of that's going to be what?
The sine of that.
So the sine of whatever this is going to be, let me see, the y value is 3.
3 over square root 13.
And I cannot have it a radical in the denominator, so I have to rationalize. Thank you. So rad 13 over rad 13. So 3 rad 13 over 13 is my sine of theta.
That's the other.
Yeah.
Well, that was easy. That was so
Marina,
much.
you okay?
Yeah.
You're mad? Mad because it was easy, or?
No, I'm just waiting for the catch.
Catch.
No.
See, that's why you don't catch. Anyway. All right, so here's some more work to pretend like we actually did the full thing. Okay, so here, where am I starting at?
Inside.
The cosine, right? The inside, the arc cosine. So inverse cosine or arc cosine, it means the same thing. So that means that cosine is what values? X over r. X over r. Bless you. So my x value is?
-5.
-5 because my r is never negative. So my r is?
13.
And I'm still missing the y. Right?
Yeah.
Okay. So, given this right here, so I'm going to have that my -5 squared Pythagorean theorem, y squared equals, that's going to give me
25.
17 squared, 20.
169.
So y squared is 144. Y equals plus or minus 12. Plus or minus 12. Okay, that's going to be important.
That's what I was going to say. How do you know which one?
Don't know yet.
R can't be negative, right?
So, but let's take a look here. I'm given the cosine. We know cosine is in what quadrants?
Cosine?
So if you guys looked previously, and I had some restrictions on cosine. Okay, cosine has a domain of what? From 0 to pi, right? So cosine goes from 0 to pi. Right, that's my cosine. And then my tangent,
Goes from -pi over 2
and it goes from -pi over 2
to pi over 2.
to pi over 2. So they only overlap in where?
Quadrant 1.
Quadrant 1. But for this to be right here, for cosine to be negative, it's got to be here, right? Okay, cosine's negative, it's got to be in here. But then because of that, it's also got to be, if cosine is negative, okay, I have to deal with it here, and then my tangent only has a restriction here and here. So I'm going from here, this is where my cosine is at right now. Okay, and I'm going to have to deal with that here in a minute. Okay, so let's take a, gotta look at something real quick, make sure I copy down the whole thing. Yeah, I was right. So it is right here, so my cosine is somewhere over here, but my tangent has a restriction of this. But then over here, since my cosine has to be in quadrant 2, my cosine has to be in quadrant 2 because of the positive and negative over here. In quadrant 2, since my cosine is negative, that means my y value here has to be positive. So we're talking about in quadrant 2 for my first value right here. So that's what I'm looking for. Okay, tangent doesn't have a place in which that the x value is negative. So that's why I can't be using that. So I'm going to be using it from this one over here. So that means that because this is negative, that means that it has to be in 2, and in quadrant 2, y value has to be positive. So this is going to give me a positive 12.
So basically, it's wherever your starting point is on the unit circle.
It
That's
gives
how
you.
know?
Yes, it gives you.
Okay.
So this gave us that since cosine is from 0 to pi, and the x value is negative, it put me in quadrant 2.
Alright.
And in quadrant 2, the y values have to be positive. Okay. So now from there, I know that tangent's what over what?
Y over x.
Y over x. So tan theta is y over x, so it's 12 over negative 5.
Yay.
Wow.
Wait, hold on.
Oh, I got worried for a second.
I know, right?
Because you said hold on. Wow.
And it's a little bit easier than what was on the notes. So, alright, blah, 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 blah. There we go, see? Alright, now, this one right here has a addition sign in between. So this one turns into a and B. So I'm going to do that right now. I'm going to call this one A and this one B. So it's a cosine of A plus B.
Are we going back to those formulas?
Yeah. They are beneficial, they are helpful, as long as we have our notes out and we're not playing with our phone.
My notes are out, sir.
So, let's start with A. So, I'm going to start right here, my A value. Now, we know tangent is what over what? Y over x. So this is tangent, arctangent of rad 3. So what is my x value in this one? It's implied, but it's not there. 1. There we go. So that my y value is rad 3. My x value is 1. Okay. So using that information, okay, remember the restrictions on my unit circle for tangent are here to here. Okay? For tangent to be a positive number like this one is here, which of these two quadrants is tangent positive? Quadrant 1. Quadrant 1's the only one that's going to work out, right?
Yeah.
So that's going to be quadrant 1, so that's helpful. So my R value is what is missing. So Pythagorean theorem, rad 3 squared plus 1 squared equals R squared. So that's going to be 3 plus 1 is 4. Square root of 4 is?
2.
So R is 2. So there's that. Now let's do the B. My B value. So arc sine. So inverse cosine. Or I'm sorry, inverse sine. So sine is y over r, right? Okay, sine is y over r. So my y value is 1. My r value is
3.
my x value is what's missing. Right? So my x value is missing, so let's take a look. So my x value is missing, so I have x squared plus 1 squared equals 3 squared. So that's going to be 1 and 9, so 9 minus 1 is 8.
Square root of 8.
X equals plus or minus square root of 8. Now, let's look at the restrictions for sine. The restrictions for sine is also quadrant 1 and quadrant 4 here, right?
But you said the tangent.
Okay, yeah. So tangent was positive, right? So that gave us for this one.
It's gonna be positive.
So now, let's take a look. The y value is positive. So if I'm looking at the restrictions of sine are these two quadrants. Where is the y value positive?
1.
Quadrant 1. So what do we know about the x values in quadrant 1?
Positive.
Positive. Very good. So this is going to be a positive rad 8. Yes? Okay. So now I'm going to do this formula here.
So
Cosine of a plus b. Remember that went, if it's on your reference sheet too.
so cosine s, cosine.
Yeah. So cosine, cosine,
Sine, sine.
and minus sine, sine, right?
Yeah.
So cosine of the first one is going to be 1 over 2. Cosine of the second one, rad 8 over 3, right? Minus sine of my first one, rad 3 over 2. Sine of my second one, 1 over 3. So for right here, I'm going to have rad 8 over 6 minus rad 3 over 6. Do they have a common denominator?
Yes.
So let's put it over that. So it's going to be rad 8 minus rad 3 all over 6.
And that's all. Yeah.
So now, that's all?
Yeah. That's it for that. I circled it, see? It's circled, so therefore it must be done.
I don't like those sounds.
All right, let's see. There's 6A. Look, I even had more space to actually do all this. There we go. 6B. Okay, 6B. This one's a little bit more interesting. Okay, it's interesting for this reason right now. Okay, I have 2 times this is my angle. 2 times the angle means it's what type of property? Double angle, very good. So that's a double angle. So I represent this thing as my angle. So now sine, arc sine, or inverse sine, we know sine is what over what?
Y over R.
Y over r. So it's going to be y value is 2, and what else?
R is 5.
R is 5.
X, we don't know yet.
Okay, we're looking for x, right? So we're going to look for x. So Pythagorean theorem right here. So it's going to be Pythagorean theorem's x squared plus 2 squared equals 5 squared. X squared plus 4 equals 25. Subtract 4 from both sides.
21.
So x equals plus or minus square root of 21. Now, again with the restrictions of my sine. Sine has a restriction from here to here, right? Sine has a restriction from here to here. My y value is positive. Which one of these has y value being positive? Quadrant 1. So therefore, x values in quadrant 1 has to be positive. Okay? So this is a positive rad 21. Now, if you guys get lost on that, I'm going to back up a couple slides to go and show you. It is in your list right here.
Yeah.
If you guys forget where it's at, okay, what I'm looking for here is this information right here. Where is it going to be found at? So it's quadrants right here for all these. These are in your notes. I can't remember. This is slide 28. So on you, it should be like the 4th page. Okay, so we got that. So now tan. So this is asking for tan of 2 theta. It's a double angle. And so it's double of what I have here. So I have to find my formula for tan 2 theta. So let's take a look. Don't worry about this. The sketch is important, but we already have all that. So tan of 2 theta is equal to, what is that? It's going to be
2 tan x.
2 tan. So for this one, it's going to be, it's not x, it's theta, right?
Yeah.
Okay, because I'm using a theta here.
Over 1 minus tan squared theta.
There we go. So I have my information, right? I went and got my information because I know my tangent is something, right? Is y over x. Do I have the y? Yes. And I have the x, right? Okay, so it's also on here from this graph. Okay, we found it on the previous page, but they're up here still. So
Why did they put it in a triangle?
it's always a triangle. It's always a triangle. It's always a triangle. So we know my y values. Okay, it's positive, so it goes up. My x values are positive going this way, and my r is going up this way. Does that make sense? And we already knew it's going to be in quadrant 1, so it had to be this way.
Oh, okay.
If it was in quadrant 4, it would
That
be going
determines,
down.
Oh, which way the...
Yeah, depends on which way it goes. All right, so this is going to be 2 times. Now let's clean up my tangent. We know tangent is y over x, right? Equals 2 over rad 21. And let's rationalize that to try to clean up my problem. So I'm going to multiply top and bottom by what? Rad 21.
So you get 2 rad 21 over 21.
Very good. So this is going to be 2 rad 21 over 21. All over. Fix that.
Looks like a 4.
Okay. 1 minus 2 rad 21 over 21 squared.
This isn't too hard.
Not.
So do you just
Okay, so
Go
this is over 1, right?
Mm-hmm.
So this is going to turn into, on top,
4.
4 rad 21 over 21 divided by 1 minus. Now, if I square these, what's going to happen to that 21 right there?
it's gonna just turn into 21?
Yeah, okay, so it removes the radical, so 2 times 20, I'm sorry, 4 times 21, right? 4 times 21 because I have to square the 2 also. It's what? 84. So it's
Wait.
84.
What?
Okay, 2 squared.
4.
4. And when I square the square root, it becomes 21, right? So this is 4 times 21. Did I lose you?
Oh,
Be-
oh, sorry.
Because
I
it's
was
2
thinking of it as
squared
4.
times rad 21 squared. Like this. So that's what's happening in the top.
I thought it was a 4, that's why I was like...
Oh, okay.
confused
Sorry,
about the
sorry.
four.
Okay.
Doesn't that look like a 4?
No, it doesn't.
Yes, it
No.
does. It doesn't
No, it
look like
doesn't.
21.
No.
Now I know. Sorry.
Okay. So now we have to square the 21 because I also have to square the denominator. So the denominator is going to give me what? So 21 squared is 441? I don't know. I'm kind of guessing at this. 441? Okay. Now, what was the trick I showed you guys with the one right here? Common denominator, right? So is this 441 over 441?
Yes.
Okay, so let's do that. So it's 441 minus 81. Please do that.
441 minus 84?
Yes. It's what? 360?
357.
Yeah, it's 357.
Okay, 357. All right. 357. That's better. So it's going to be right here. 4 rad 21 over 21 divided by 357 over 441.
And then you multiply the reciprocal.
Now I'm going to multiply by the reciprocal. So let's take a look. So it's going to be, was it, did I say 2? No, it's 4, right?
4 rad 21 over
Yeah, there we go. 4 rad 21 over
21.
divided by,
357 over 441.
there we go. So now I can take this and multiply by the reciprocal. So that's going to give me 4 rad 21. I don't know, why am I doing that? Okay. 4 rad 21 over 21 times the reciprocal. The reciprocal of this, I'm going to flip this over. 441 over 357. Is it 357?
Yeah.
Okay, yeah. I know this is going to reduce by at least a factor of 21. So you guys could do this part in the calculator for me. So 4 times this time, yeah.
Wait, do I leave like 4 rad 21 times?
Don't put the rad 21. You could probably reduce this.
4
So
times
this
21.
reduces by, so that's 21, that's 1. So it's going to be 84. So 84 rad 21
21 over 17.
over 3, 5, 7. 84 over 357 reduces?
To 4 over 17.
4 over 17? Okay, very good. So it's going to be 4 rad 21 over 17. So this is the part that you put in the calculator, the 84 over 357 to get that piece to reduce.
You're gonna murder me, aren't you?
I would like to.
I know what's happening. I understand this.
Please. That's a lie.
All right, is everyone okay with this?
Yeah.
Okay, let's see. All right, so that's it. I'm actually skipping those examples, example 7. So your homework, don't forget about your homework. The homework problems that I gave you guys for this. We'll use the rest of the time to actually work on what we need to. And yeah, don't forget, like and subscribe.